Hello students, I am Anu John. Today we are going to discuss some topics on chapter Electricity from class 10 Science. Electricity has an important role in the modern society. It is a most controllable and convenient form of energy which can be used for a variety of purposes in homes, schools, hospitals, industries and so on. Now let us understand or recollect some of the topics that you have studied in your lower classes based on this topic. What are conductors? Conductors are materials which allow electric current to pass through them. Conductors usually have free electrons and metals are the good conductors of electricity. What about insulators? Insulators are those materials which does not allow electric current to pass and they doesn't possess free electrons. Non-metals are examples for insulators. Now let us recollect what is an electric charge. Who carries this electric charge? Electric charge is carried by tiny subatomic particles. Positive charge and negative charge is present. Positive charge is carried by protons and negative charge is carried by electrons. When two positive charges or when two negative charges, that is like charges, come closer, they will repel. And if two unlike charges comes closer, they will attract. That is, one positive and negative comes closer, they will be attracting. And we can see number of protons and electrons in the objects that we see around us. And in metals, these electrons are in random motion, whereas in non-metals, their position is somewhat fixed. They are not able to move. Children, you are familiar with air current and water current. Flowing water produces water current in reverse. Similarly, electric charge flow will produce electricity or electric current in a conductor. If you just take a metallic wire and if you connect it across a bulb, will it glow? No, because current is not passing through the conductor. So some device is required for the flow of current through a conductor. Cell or battery can be used as a source of charge in order to give the electrons the energy to move from one point of a conductor to another. So how can we define or how can we express electric current? Electric current can be defined as the amount of charge flowing through a conductor through a particular area in unit time, or it is defined as the rate of flow of charges. So, electric current is found to be flowing from positive terminal of the battery to the negative terminal of the battery. So, conventionally we take the flow of current to be opposite to the direction of flow of electrons. Now, we can mathematically express current. Current can be represented as I. So, current I is equal to rate of flow of charge, that is Q by T, where Q is the charge, that is net charge passing through the conductor, and T the time of flow of charges. Now SI unit of charge is coulomb and it is represented by capital letter C. 1 coulomb charge contains 6 into 10 raised to 18 electrons. And what is the SI unit of time? SI unit of time is second, as you know. Now let us see what is the SI unit of current. SI unit of current is ampere, represented by A, named after the French scientist André-Marie Ampere. Now, can we represent current in terms of ampere, or can we define 1 ampere current? 1 ampere current is that current flowing through a conductor if a charge of 1 coulomb is passing through it in a time of 1 second. And can we measure current which is passing through an electric circuit? Yes, we can do with the help of a device called ammeter. Ammeter is connected in a circuit in series so as to measure the current in the whole circuit. Now let us recall what is an electric circuit. You have already studied that in your lower classes. Electric circuit is a closed path where electricity moves, or it is a path of flow of electrons. Now we have studied what is an electric current and how is it produced. Now let us see what is the reason behind the flow of electrons in a circuit. You know that cell or battery is a device which helps the flow of electrons in a conductor. Now consider two beakers kept at same level from the ground, and we have water filled in these two beakers, and the water filled in this beaker is at same level. And now a horizontal tube is connected to these two beakers. Will the water flow from one beaker to another? No. Water won't be moving from one beaker to the other. Now, if you want to make the water move from one beaker to another, is it possible? But we are not allowed to add or remove any amount of water from any of these two beakers. But it is possible. We can just raise the beaker towards the height. One of the beaker only towards the height. So what will happen? The water from the beaker which is at the height will move towards the beaker which is kept down. Why does this happen? This is because there will be a difference in pressure at the two ends of the horizontal tube when one of the beaker is kept at a particular height. So this difference in the pressure of water at the two ends of the horizontal tube makes the water to flow from beaker one to the other. That is the beaker at a height to the beaker which is kept down. Similarly, for the flow of electrons in a conductor, we need a difference in the electrical pressure between the two ends of the conductor. And this is actually provided by whom? Provided by cell. And this difference in potential provided by cell is called potential difference. So what does this cell do in order to provide potential difference? Inside the cell, some chemical reactions are occurring. The chemical reactions happening inside the cell will set the charges in motion, because these chemical reactions inside the cell will produce a difference in potential between the two terminals of the cell, and thereby the charges are set to move. And when these charges move from one point of the conductor to the other, it is utilizing the stored chemical energy given by the cell. So, for continuously supplying energy, the cell has to give continuously this chemical energy. Energy given by, or the chemical energy given by the cell is utilized by the electrons to move from one point of a conductor to the other. So, we can define potential difference as the work done in moving a charge from one point of a conductor to another. So, how can we mathematically express potential difference? Potential difference is represented by the letter V. So, V is equal to work done divided by charge. So, we can write V is equal to W by Q. And we are having a SI unit for potential difference also, and the potential difference is having the SI unit volt, named after the Italian scientist Alessandro Volta. And can we define what is 1 volt? From formula you can write 1 volt is equal to 1 joule upon 1 coulomb. So we can define 1 volt as the potential difference between the two ends of the conductor when 1 coulomb charge is flowing through the conductor by doing a work of 1 joule. We can measure the potential difference between the ends of a conductor by connecting a voltmeter. For measuring the potential difference, voltmeter is always connected parallel to the points of the conductor of which the potential difference is to be measured. So I hope you have understood what is electricity and potential difference through this module. Thank you.